Hello, welcome to the very first open building live stream. My name's Thomas. I build land octals. I'm a landscape architect and computational designer. More of a computational designer these days than landscape architect. But yeah, I thought this would be sort of a good opportunity to, I don't know, show people what I do to develop land octals, especially the architecture community. I think learning to code as an architect is one of the most powerful things you can do. You sort of get your get control of the tools you're using, you know. And just let me know if the audio is a little bit too loud. I'm looking at the levels and trying to adjust them. So there might be some some glitches and things. I've tried to smooth out everything as much as possible, but you know, this is a learning experience for me, and hopefully it'll be kind of interesting. So I'm gonna sort of do these in a way that will be applicable to YouTube later. So everything's recorded and added to YouTube for people who can't make the live streams. But I'm going to try and do this once a week. I think it's going to be really nice and educational. It's going to be quite beginner friendly. I'm going to explain most things. So if you don't know how to code, and you're interested in architecture and how it can be applied to architecture, this could be really cool, and maybe spark some interest in you, because I know from my experience, I don't know any coders. Certainly within architecture, it's quite rare to find someone who codes or is interested in it. So that's it. That's the introduction, I guess. So basically, I'm just going to go through what I would normally do on the weekend and code, but I'm just going to add on some additional things, like explaining what the scary text is doing and hopefully make it less scary. It's not scary at all. I mean, I write code in a way that's very like I'm assuming quite naive because I'm not a software engineer. I'm a designer foremost. So I write code in a way that I can kind of understand it. Yeah. So I have a few notes. So I get people complaining mainly about some things that don't work, or when I'm using the tools, I realize I've coded something badly. So the first thing I want to do is this guy here. So this one's an embarrassing one. So the embarrassing ones get the most attention generally. So I added like a dynamic draw function into my tools recently. And to do that properly within Rhino, I have to be able to scale to the right scale, depending on what the user picks. And my cat's attacking the door because he's unhappy I've closed the door. So if you hear like a weird like "Wah!" that's my cat. I just realized you can't see my screen. Yep, that's what I was going to say about, maybe some roughness around the edges of presentation here. But yeah, so I've just gotten into Notion, actually. Notion is really great. I used to use Todoist. Well, I still use Todoist. But that's sort of, I think that's a lot better for kind of simple tasks, like your boss has given you this task, write it down and then tick it off. For actually creating like an entire add-on and tracking like what people are asking, what people are giving feedback for, like the branding of it. I got branding notes. At the moment, it's literally just what colors do I use for this thing? But for, yeah, I mean, for more complicated or complex things, Notion is really fantastic. Anyway, I've got a little tracker of things. The first thing we're going to look at is fixing the scaling on the RL dynamic draw function. And I'll just demonstrate why that's wrong at the moment. You can see the dynamic draw is this little crosshair I've got, and the little point which tracks the height. So right now I think that's okay, but if we look at the units, it's probably because I'm working in meters, so I always work in meters. So usually these glitches happen when I haven't bothered to test, like if we go into millimeters, how big is that? Yeah, so something weird's going on. I don't even know where the circle is. It's probably, yeah. So let's have a look. So this is the code here. So this is all written in Python. It's written in Python, written in VS Code. So VS Code at the moment is set up to send code to Rhino using an add-on called Rhino Python. Rhino's sort of going through a little bit of a transition at the moment into Rhino 8. They're sort of building out a proper code editor with actual good integration into external IDEs like this. But yeah, that's a sidetrack. At the moment, my point is that it's not super easy to develop in Rhino, just because there's a lot of setup and you can't just like start and go. But we'll make do. Hopefully this is big enough for everyone to see. It's crazy large for me. So we'll see. Okay, so what's happening here is we are looking for the scaling definition. So this is doing a number of things. This is looking at what the current document is doing, what unit scale it's using. So that's what this is doing. It's basically going, what unit scale are you using? And it sends a number, and the number corresponds to, if we have a look, to one of these units. What we can then do with that is basically Rhino has built-in scaling functions to then scale whatever scale I'm using within here against whatever is being used in here. So something is going on here, and usually when I have an issue, it's because I'm not summoning the function properly. And my cat's attacking the door. I'm so sorry. It's all right, bud. He doesn't think it's gonna be okay. He thinks I'm dying in here. I know. Okay. So this is the dynamic draw function. So what happens basically is if we just collapse this guy and have a look at what's actually happening. So when we run this thing, right, what happens is it skips this function because these definitions, are not run until they're called upon. So it goes all the way down and it says, okay, construct get point. And then, so we construct this get point, and then when we say, okay, before you go and get that point, start this definition and keep doing it until we press get. So then it goes up here goes to the dynamic draw function, and it starts this logic here, and basically it's looping through this logic every time you move your cursor. So it's very rapidly cycling through this, and it's kind of like animation, you know, like you're setting up a keyframe to like go from point to point, but it's just like flicking through this up and down, up and down, up and down. And when you look at that, you know, that blue crosshair there, that's just one image and then just shuttered continually, if that makes sense. So this isn't working. So it's probably because circle. Oh, okay, circle. So see, we've got this function here. Basically what this is doing is when we start the thing, and I can probably, oh no, that's fine. So when this starts, it's asking for the scaling of the system, and then it's passing back the scale translation, basically. So like, how do you get from meters to millimeters? So that's what this is saying. This is constructing a circle, right? So it's going rhino geometry dot circle. That's like the constructor command. And to create a circle, we need to know the center of it, and then we need to know how big I think it's diameter in this case, or that could be radius. I think generally it's probably diameter. And then we're scaling that, so we're timesing it by the scale. And that gives you the size of the scale at appropriate size. So what I think we need to first double check, and this is always the problem with working in a blank canvas, is you don't quite know how big anything actually is. So if we go, so that's a meter, 1,000 millimeters. So you can see like we're actually quite zoomed out. So you can see, yeah, that's not working at all. So may have to stop talking for a second here and actually have a look at the code. So I think probably, yeah, I think the lines aren't being scaled properly. So how are we creating the lines? We're going from the cursor point, and then we're constructing another point from the cursor point. Okay. Okay, so this needs to be scaled relative to the document scale. Okay. So what we'll do here is we'll just go times scale, and we might just plonk that into its own brackets, and then plonk this into its own brackets just in case. No, wait, yeah, let's try that. Let's just test that to see if one of the lines are bigger. I think so, yeah. I'm just gonna the precision. I think that's doing something, so let's have a look. The other thing I just want to do is print scale, just to see 0.001. No, that's wrong. So this is why you should always see first what's actually going into these functions. So this is scaling the wrong way. It should be scaling up to, oh no, that's right. No, this is where it gets tricky, right? So we're internally we're working at meters, and externally we're working at millimeters. So this needs to actually scale the opposite way. So it is wrong. So this needs to scale by 1,000 to get to a meter, because it's going from here into here, not here into here. Yep. So we need to go back to the scaling function and change, well, first we need to check the documentation. I believe you can find it here. So millimeter is 2. So we're gonna change this guy to 2. I'm just... I have my doubts about this. No, okay, that's also wrong. Damn. We run that again. 0, 0. So I'm seeing the result here, by the way. 0, 0, 1. We need to inverse that. Why is it doing that? Both my cats are going mental now, by the way. God, why don't cats like closed doors? Okay. So this is where you get to see how much struggle there is to like solve simple math questions. I think what I need to do to reverse this is swap this with that, and that should reverse it. No, that has failed to execute. Interesting. I vaguely remember trying to solve this problem, so I'm just blindly like changing. Why is it failing? Yeah, that's system enum to object. Oh, okay. So I should really read the code before. Actually quite hard streaming and using what brain power I have left. By the way, I have COVID. So I'm also like working on trying to survive. But yeah, there we go. We've got 1,000, so that's the right scale. So I was, yeah, I'm gonna blame COVID on that one. So these are construction things. So the system to enum to object, that's actually constructing the thing. So that has nothing to do with the actual scale. So just reversing these means that we're working to the right scale now. So I've been really sloppy with it. Some of the code works internally with like meters or millimeters, so I continually get this error here where I'm scaling internally to the wrong, like internal measurements, to the external measurements. Whoa, there we go. Look at that. So we are now scaling properly in some of the measurements. Okay, so we can get rid of the print scale. Now we just need to do this for these line constructors here. So what's basically happening in this code, right? So when that get point thing is triggered, and then this is triggered here. Oh, that's too big. What then happens is the cursor has continually updates its position, and we can use that as a defined world coordinate point. So a point has an X, Y, and Z coordinate. What we can then do with that is start constructing geometry. And this display pipeline is literally just displaying like geometry. It's not anything fancy. It's just like what you would work with within Rhino in the first place. So it's literally first builds a circle. So circle, rg.circle, that comes from this. So we're importing rhino.geometry as rg. So when you start working in Python, you'll be working in sort of these libraries. And Rhino has two libraries, confusingly. One's called Rhino script syntax, which is sort of like a library that McNeil wrote to make very quick scripts in Python. It's very powerful. But if you want to do more complex things or be slightly more efficient with your code, then there's a second library called Rhino Common. And that's effectively what Rhino script syntax uses anyway. It just has a lot of additional code that it kind of bundles together. So if you want to do this kind of dynamic draw, you have to go into Rhino Common. If you're sort of starting, I would point you towards using Rhino script syntax, mainly because that's what I did, and it's a lot easier. There's a lot less kind of things you have to think about, and then once you're ready, you can go into Rhino Common. You know, I have heard a few people who will be like, "Oh no, don't use Rhino script syntax. It's inefficient." It's like, what are you building? Like, if you're not building simulations or anything super computational complex, and honestly, like if you're just learning coding, like I don't think you're going to be doing that. So just do yourself a favor and use the easiest thing. Don't get caught up in trying to learn Rhino Common first. Anyway, that's something I kind of disagree with. Anyway, that's a side tangent. So we're finding the current point, and then we're building geometry aligned with that point, right? So the circle, we've got the current point times 1 meter in this case, because internally we're using 1 meter, times the current internal scale. And then we're constructing 4 lines, and that is the crosshair. So line 1, line 2, line 3, line 4. Rhino geometry.lines, so this constructs the thing, the concept of a line, let's say. So constructs the concept of the line, doesn't actually put the line anywhere, just has the concept. So it's like an object in the ether, right? If you've used Grasshopper, you might kind of be more familiar with this. We've got our current point. And then you can see that we've actually got another conceptual constructor here for point 3D, right? So what we can, gotta go to my thing. So we're constructing a third point, which is the other side of the line. And we're just saying, we're deconstructing a point and being like, the point's going to be the same as the current point in y and z coordinates, but in the x coordinate, it's going to be 1 meter longer. And then we just do that for all the other ones. So that kind of creates the crosshair from the origin point. And the issue we have at the moment is that I didn't add a scale to this. So the difference between here is this is longer and this is shorter in the x direction. Then we'll just do that for this as well. So now this becomes longer in the Y direction, and this becomes shorter in the Y direction relative to the scale. And if we run that now, voila, we have 2 meters. And that might be a bit too big. A sort of thing is, like, you never really know how janky all of this stuff is until you start using it professionally. So that's how I debug all my stuff, is I use them at work. And then the weekend comes and I'm like, that's so bad, just change it. So yeah, we'll see how this kind of reads, but that seems to be working with the scale now. So I'm just going to go and save that. And if we change this to miles, so we're changing not just the that might have been a bad choice. Anyway, we'll have a look. Yeah, actually need to change, check that. So let's just go back to meters. Make a 1 meter reference circle. You've always got to have a reference. Okay. Just checking how big this is. Yep, 1 meter. So let's run the script. Yep, so this circle's about 2 meters. And now I'm just going to go and change the units out of metric into the forbidden imperial. And we'll just see if it actually correlates. Huh, that's weird. It's not out, but it's... I mean, it doesn't really matter, but it's slightly different. It's like it's like a quarter or a third. Interesting. I mean, I can't read imperial. So that's 3.28 feet. I'm guessing that's a meter. And that again. Yeah, that's so weird. I must be doing something weird in the scaling. Maybe this... Yeah, okay. So this probably also needs to be flipped. This is the problem with using measurement systems that you have no understanding of. I don't understand how anyone uses bloody... There we go. Imperial systems. I guess Americans feel that way about metric as well. But yeah, that's working now. That's great. So that's why you always have to check. Like, it is a lot of this is just checking like every single situation in which this. I don't go through all of these. I mean, I'm not sure why it has light years and parsecs. I think that's just a joke. But you can see like this is doing a few different things. Like when we go into Imperial, it actually changes the RL heights to feet and the meters. When we're in metric, it's in meters. And I just want to check when we've actually got height. Yep, you can see that it's updating that text dot dynamically, which is fun. Which is really useful just to like probe the model to see where things are at, so you don't start like tagging everything. And that's the other sort of feedback I got with this, is that people are tagging their model and then they end up with a million of these dots everywhere, and they want a tool to turn the dots off and turn them back on, or yeah, basically turn them off. So probably not going to get to that this one, but maybe next week. My thought is basically when you double click these, it has some secondary text. So my thought is that I'll just add some secondary text as an identifier for these dots. And then with a second tool, I'll have something that sort of scrapes the model and looks for this identifier and then turns them off or hides them or something. Probably hide. No. Yeah, maybe hide. Maybe. I can think of two ways to do it. Either we do that, we put some identification in the secondary text and then turn them off, as in hide, or we put them on a dedicated layer. My thought is that if it's on a dedicated layer, that's a little bit more user friendly, because then the user can go in and turn those layers off instead of just using the tool. And sometimes like hide is one of those commands that not a lot of people know about, or like if you're just starting Rhino, you're probably still using layers to show and hide things. Whereas I don't use the layers or locks or anything. I mainly use these kind of tools here to kind of isolate things, and I mean, I do put things into layers, but I don't like hide them in the layer or lock them, because I find that actually tends to make interacting with the model kind of hard. So yeah, there's potentially two options there, and I actually might note that down. Have I not? Oh yeah, there it is. Where's edit? So, either use hide or add to layer with hide layer option. Yeah, I mean, whatever people are keen on for that one. I think hide is sort of a little anti-user, because people can get sort of locked up with being like, nah, it's disappeared, and they don't know there's an unhide command. If you don't know, hides like a piece of geometry, and then unhides it. Oh, not unhide, sorry, show. Show. Okay. So we've fixed our first bug online. Hopefully I mean, you can see like a lot of it's kind of just been like, what does this do? What does this do? Especially for me, you know, as again, I'm not a software engineer. I'm just trying my best. But yeah. Yeah. The other thing I thought is that could maybe do some, you know, Grasshopper tutorials and things, although I think that's been done like a million times already. But has it been done live? Don't know. It probably has, actually. So maybe we'll do that. I'm trying to learn C# at the moment, because I want to develop some Grasshopper scripts that actually need to run fairly efficiently. So Python's amazing in that it's super fast to write, super easy to read. Like all of this really reads quite like English. C Sharp's okay. It still reads fairly well, but it has a lot of other kind of additional requirements, which, from my point of view, just seems like flamboyance. But I'm sure from a software engineer's point of view, it's necessary, and they probably see Python as unequipped, maybe. That's the other thing. Like people are really, really passionate about their what's it called? Language of choice, right? But I'm speaking purely from someone who doesn't get all day to write on code, or has very little time to spend on coding and just needs results. And for that, Python is excellent. Like if I'm modeling a landscape, let's say, and there's a certain issue that is obviously able to be automated, I'm not going to be writing C# code for that, because it requires compiling, and it's hard to debug just on the spot. Whereas Python, you just slap something together and make it run. So from like a kind of dynamic point of view, it's really fun. So yeah, that's why I kind of recommend, like, if you're not a software engineer and you just need stuff to work, Python's a really great starting point. And it has interoperability with Grasshopper as well. So if you're using Grasshopper, you can really take your Grasshopper scripts to next level. It's not even like taking Grasshopper scripts to the next level. It's like sometimes you just want to clean up a Grasshopper script so it's not the size of Mount Everest. And you can really just rationalize a lot of Grasshopper functions within a single Python function. Yeah, but as I said, I'm working on some Grasshopper scripts which are fairly intense. So unfortunately I have to learn C#. Yeah, so I'll let you know how I go with that. I probably won't do that one on stream because learning a language is highly embarrassing. It does make you feel very small. Yeah, cool. So we're done with that. What was on my other? I got a request on Food for Rhino to add a grade by height option. So this one is probably my favorite script that I've done. Not because it's complex at all. It's very short, actually. It's only 84 lines of code. But basically this is quite big for a landscape architect, because to grade a curve in Rhino is quite hard. Like you might be like, oh, well, you just move that curve up and you've graded it. But if a curve has like multiple points, how do you grade that curve, right? Are you moving things individually like this, and then those curves could be like, in the worst situation, those curves can be using Bezier curves, right? So how do you grade that? That's quite hard. So what the script does, and I'm just going to black out the screen here, and draw. So say you've got like a curve, right? Like this. And you've got control points along this curve, like that. What this is doing is basically it looks at the curve and says, okay, so you want to grade 1 and 20. So it gets the parameters of the curve. So a parameter is like, you can describe any curve as 0 to 1. And a parameter, so like the midpoint, like here, would be a parameter of 0.5. And this would be 1, and this would be 0. So this would be, oh god, I'm going to show my maths. I have no idea what that, I'm not going to try and do that on stream, but you get the point, like it's 0, 5, 1. So what it does is, and actually this is sort of why I started to code, because there's a bit of maths in landscape architecture, especially with grading, which at the moment a lot of people do manually. I'm freaking hopeless at maths. Lucky for me, I can code and I can get the computer to do that for me, so I don't have to think. And that's where a lot of my doctors come from. It's just being terrible at maths. Yeah, anyway, because computer's just a big calculator. Anyway, so it looks at the parameters, right? A parameter, again, goes from 0 to 1. And it says, okay, so parameter at 1 would be this height at this grade. Parameter at this point would be this height, and then down here. And then it rebuilds that curve like that. So hopefully that makes sense. So there's a little bit more maths involved in that to get the heights on a certain grade. So like a 1 and 20 grade, like that would be that height, and then that height. So I've gotten a request to do that by height, which I'm not really sure what the use case of that is. Why would you be grading by height? I have no idea. But that's easy to implement, because what we can think of parameters as is percentages, right? So this is 100%, that's 0%, and that's 50%. So if a user inputs like 3 meters, then 100% of 3 meters, 50% of 3 meters, and then 0% of 3 meters, and that would get you the grade. So yeah, so let's attempt to do that on air while also talking, while also sick with COVID. So first we need to find so I'll just show you the tool running actually. So it's this guy here with the little, is that, no, which one is it? It's this guy. I just changed the icons, so I'm still a bit confused about what's what. But this is the grade curve tool. So if we click on this, it asks for like a grade, and the default's 20. And you can see it's gone through each of these control points as parameters, and it has moved them to the right spot. So basically what this guy wants is, when we select this, going to want an option of either the grade, and I think the grade will stay the default, or the height. So from a user standpoint, what's the easiest way to implement that? I guess it could be a check of there's no user input, it goes to enter height. That could be sort of a hidden feature, because I think generally this is going to stay as grading rather than height. So maybe it's just a fallback option of, okay, wouldn't you put in a height then? Yeah. Let's do that. Because I personally, I don't know, like, why. I'm going into the red with my voice here, so I'm sorry if that's kind of popped your ears. Yeah, I can't work out why they want a height one, but I said I would, so I will. By the way, like, giving me feedback is probably the best thing you can do. You know, it's a small community, so if you want to give me feedback, that's fantastic. So get my brain working again. So a lot of the time you kind of forget what you've written, and you have these little tags here. These are comments, so these aren't actually run by the code. So we just have to reacquaint ourselves with what is actually going on in here. I actually have an unused variable here. Interesting. So the first thing we want to do is introduce the fallback of the enter height. So here I'm using Rhino script syntax. So this is what I started with, and generally, like, when I'm just wanting to get user input, Rhino script syntax is a really good library to use because it's already built for you. You don't have to do all the finagling. So if you're just doing like simple user input, super good. So we can see here what this Rhino script syntax.object is doing is it's asking for the user to select the curve. So we've got options here: get object to grade, and then the filter of 4. So I think 4 is a filter of a curve, so you won't be able to select anything but a curve. This just stops potential errors going down the script. And then there's just like additional optional behaviors of this thing. So pre-select is like if the object's already selected, then it'll just take that as the object that you want to grade. And then it's basically here it's saying, okay, well, if you didn't get a curve, just return, and actually this should just return false. So if it doesn't get anything, it just ends the script. So if we are in here and just exit out, you can see nothing happens. Actually, we should put some more information there. So we'll go print no curve selected. So when we run this now and we don't select a thing, a little prompt comes up saying no curve selected, and then it returns false. So if we don't catch errors like this, scary errors pop up for the user, and that generally turns people off. So I'll try and catch most of the errors, but that's kind of new to me as well. I'm just learning. So then it's asking for, so these little things where it goes grade equals, that's called variable. Variables are often described as little buckets, buckets of information. So we're creating a little bucket of information. Well, it's an empty bucket here, but then that empty bucket is going to be filled with this information that we get from the user. So we're going Rhino script syntax dot get real. That's not an insult. That's asking for a real number. So real number is an integer. Different. Oh god, if I got that wrong, people are gonna be on my case. But it depends. They're sort of described differently in different programs and things. But a real is a integer, and then you have other numbers called floats. I believe they're called other things as well, but floats are basically this thing here. And I'm not actually sure why I've got... Why have I got a minimum of a float and not an integer? This is great. I'm picking up my own silliness. So basically this is asking enter the grade, and then this number here is the default, so if nothing is entered, this is what will be used. But I may get rid of that, and I just want to see go back up to the top. Get real. I just want to see what happens if we don't. Yeah, it's optional. So if we don't put a default, it's going to return none. So we can use none as a way to fall back onto a second option. So we are going to get rid of this dude. And does the minimum want to be 1 or 0? What happens if we put 0? No, because 0... So 0 would technically be vertical, but I think in this case it just sees it as nothing. Interesting. We'll keep to 1 because generally ain't no one going above 1 to 1. So that's 1 to 1, right? So for every 1 meter, it rises 1 meter. Okay, we'll just leave it at that for now. I'll have a think about it. If you're going above 1 to 1, you've got other issues. Okay, cool. What are we doing? So this grade will return none. So what we can do is just print a test. Just print test, just to see if it is falling into that. And then, yep, so you probably can't see it, but up here it says foo. So this is returning none, so this is saying if not grade. So if not, it's just asking like if there's nothing in here basically, and none is a nothing. Do the following. So now what we can do is go and do we? No, we want to get a float and potentially get int. No, get. Or is a real number a float? Oh god, I hope I didn't get that wrong. Get real. Oh, shiza. Oh, people are gonna be so angry at that. I'm so sorry. A real number is a float. Integer. Damn, I am so sorry. People are gonna be angry with that one. Oi. Yep. A real number is a float. I'm so sorry. So this is a real number. An integer is what we had before. Oh man. This is the great thing about being live. You can show the world how bad at coding you really are. But hey, this makes me face the realities, which is fine. So that's fine. I'm glad I picked that up. So that was fine as it was before. I get real. That's fine. So what we'll do if nothing is, I know this is really bad, but I'm going to call the the variable. I'm going to call the variable the same thing. So it's not technically a grade, but it just means I don't have to change anything downstream. So we'll go rs.get real, and then we'll say, just gonna copy this. And we're gonna say enter height. Instead, just say enter height. I guess this is going to be a slightly hidden feature. So enter height, and we'll just put xxx. No, we don't need that. Enter height. Minimum, probably. Yep, that's fine. Maximum, none. Maybe we do want that to be, yeah, we do, because that's going to be completely different. So, we're using camel case. So camel case in programming is you've got the first one is lowercase and then uppercase for each kind of word after that. So this is slightly grayed out because it's a variable that's not being used. That's just a way of catching unnecessary variables. I feel so bad about not understanding what a real was. Let's blame it on COVID. Blame it on COVID. Just gonna hydrate. Okay, so now we've got a fallback. We do not want to return in that case, but what we do want is if not height, then print no user input and return false. So let's just check that. We're not going to return anything, and yeah, so it says enter height, it doesn't get a grade, then it asks to enter height, and then no user input. I might go enter height instead. Try and make it clearer. Maybe we can make that a little bit more obvious later. Yeah. I'm basically building this for one guy. and I don't want to subtract from the original functionality or intent. So enter height instead. Now we've got our old fallback, and then to exit the script if nothing is inputted twice. So what do we do now? We now need a different track for height. So we've got a track for grade. So once we grab grade, what's done with the grade? Yeah, so we have our basic rise equals run divided by grade. And that gives you, yeah. So this is looking at each grip. So grip on a curve is this little white dot here. And then what I remember I did was that I'm basically projecting to the closest point on that curve and finding the parameter from that. So what we're doing is basically going through each thing, each parameter, and being like, what's the length of this parameter? What's the length of this? So this is a for loop, right? So it's looping. So for I in curve lengths. So we've basically got a list of curve lengths from this point to this point at each grip. And then what we do is we're creating a list. So this creates an empty list here. Empty list in Python is 2 square brackets. And then we're going rise equals I divided by grade. And that gives us our rise. And we're appending that rise to the empty list. And then what we can do then is basically move each grip up in the Z direction by the right thing. So basically, like if we were to do this by hand, it's going, this one goes up this high, 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 and this one goes up this high. Of course, the machine can do that faster and way more accurately. That's what I actually really like programming in Rhino is, you know, as someone without a computer science background, I find it so much easier working with programming in 3 dimensions. Because I guess that's also my background, is I work in Rhino every day. So it just makes it easy to kind of understand. But yeah, it's these kind of workflows that you start to see when you're, you know, working generally. They're like, oh man, like a robot could do this like in 2 seconds, not even 2 seconds, like fractions of a second. That's where all these tools come from, you know, is identifying those kind of things. So this is where, so we have an unused variable there, so I'm just going to delete that. I'm just going to double check that still works. No. Was that because I... Oop. What have I done? What did I do? So I've got these, what's happening is I have these try and accept things encapsulating like all of it. And what that's doing is making it very hard to debug, so I might actually get rid of those for now. Where's the accept? I'm not going to delete them. I'm just going to comment them out. And then I'm going to have to... What do I have to? No. So now I'm actually getting the errors. So, line 46, local variable height reference before assignment. Oh. Oh, okay. Rookie mistake. So this needs to be indented one more. Yeah, there we go. So what happens there is basically, so the logic is asking for the grade, and then it was like, okay, if there's no grade, do the height. But what was happening is when you enter a grade, it was flowing down into this if not height, print no user input, and that was getting an error because you can't, you have to substantiate the variable before you kind of use it in any kind of logic. So now that we've indented, this is called a block, and you can kind of see these little colored spaces. So these kind of, if you're familiar with like grouping in Rhino, is how I would explain it. That's kind of like a block, right? You have like a group of code, which relate to each other. So that was all that was happening there. So yeah. Oh. Thanks for following. The cat meow scared me. Hey, thanks for following. Completely blew me out of that. Yeah, so that's really it. So now that we've debugged that, let's find a separate track for grading by height rather than by grade. So I just need to put some logic in that separates the two. So what's this doing? Find length of curve at each grid point. Curve length equals. Okay, so this is enabling the curve grips. So what that's doing is in the background, it's making these appear for some reason. And I remember this being a bit weird, is that these don't seem to exist unless you enable them in code. I mean, they exist, but if you don't go enable object grips, it doesn't exist for some reason. So then we're creating a variable going rs.objectGripLocations. So this is giving you a list of points, which are these little doodads. And then what we're doing is basically we don't really care about these grips, right? We only care about where the closest point of these grips are compared to these handles. So what this is doing is finding the curve closest point to these points. So this is projecting it straight there. So once we have that, we can get the curve length of each point along that curve. So I think all of this code here is relevant to changing this to grade by height. So we need all of that, so that's fine. And then this is not relevant. So this is where we insert our logic. So we go for this particular one, if grade. So if grade is just asking like, is there information in grade? If so, do this. And then we'll just add this into a new block. So it goes if grade and then do this. So I'll just check that this is still working. I've not done something weird. Yep. And then if not, yep. Okay, great. So we've successfully split the stream of logic. So if we go, what's the time? 11. Then we can have a second stream of information. If height. So again, this is, and you could probably do this with else. Probably safer to do it with else, but for now I'll just put it as if height. So if there's information in grade, do this. If there's information in height, do this. So what we'll do is so we need to do something similar to this. So what we're gonna do is copy this. So we create a empty list for the grip heights, and then we start looping through for I and curve lengths. So curve lengths is a list here, and we are going rise equals I divided by grade. So I need to find, basically I need to divide the entered height, find percentage, get the percentage of that height, and then apply that to the grip height. Right. So that would be, so let's just call it G height for grip height equals height divided by 100, no. So the parameter is the percentage, right? So I in curve lengths. Okay, that's not useful. So we're not interested in finding the curve length. We are interested in getting the parameter num. Yes. Okay, damn. Okay, so what we're going to do is move this up here because that is actually not applicable for the height. And then what we're going to do is just get this block of logic. Oop. And paste it into our height block. So this gives us our parameters, and I just want to going to comment out that for now, and I just want to print param_num just to see what's coming out of there. Okay. So these are not reparameterized. So when I was saying parameters are 0 to 1, that's a reparameterized parameter. So these are kind of the raw, like basically distance of each thing along that curve. So if we vaguely measure that, yeah. So that would be the entire length of it, and that would be the start of it. And these are the kind of things in the middle. So we need to reparameterize that. And God, that's a math thing. So this may take a while. Hopefully Rhino has curve closest point. Oh no. The COVID delirium's hitting me. Okay. Length. Okay. Converts a normalized curve parameter to a curve parameter. That may be it. No, that's converting it the other way. I think this is what we want. Converts a curve parameter to a normalized curve parameter, one that ranges between 0 and 1. Okay, let's use this guy. Let's try this. We want rs.curve normalized parameter. The curve ID. That's a good question. Where is the curve ID? Just curve. So CRV. And then we're going to go parameter. The parameter is param_num. And we'll just go norm param equals, and we'll print norm param. Let's see, so this is, we'll go 10. Yeah, perfect. So this is what we want. So 0 to 1. So what we can effectively do is use these as a percentage, and basically say 83% of the original height is what you need to move that grip to. So let's uncomment those and go grip height grip height equals, sorry, it's COVID delirium. Okay, so grip heights creates this empty list for I in curve lengths. Do we want to do that still? No, we don't want to do that. What we want to do, so what's going up here? Yeah. So we want to basically param list equals empty list. So we need to make an empty list, and then we need to go param list dot append. So what dot append does is basically add that data to a list. So each loop adds an additional piece of information to that list, and we just want to add norm param to that list, and then we go for eyeing. Do we want grip heights? Yeah, so maybe we don't need that list actually. So we can put all the logic in here basically, I think. So what we want to do is go grip heights dot append, and I'm just going to, yeah, okay, I don't think we need this list. So going grip heights dot append, and then we'll put some logic in there and say, so what are we doing? So we want the height of the grip at that point. So we go so norm param is basically the percentage. So we want the height divided by 100 times the normalized parameter. I think it's right. So that gives us, so this divides it into 1% of the height, and then we're timesing by the percent that we need. So that gives us, like, if it's going into this one, 83% of the original height, I think. Yeah, I'll just put spaces in here to make it more readable. Yeah, so that's the grip heights. So that's appending the height to the list. So this would be 0, that would be 17%, 31%, 63%, 83%. And then what do? We move the curves in that height direction. Do we need to add scaling? I don't think so, because we assume that the user is inputting that data at the scale that they're using. Yeah, so we don't have to do any scaling internally. Probably never good to assume something though. Okay, so for I in curve lengths. So now that we've got a list of grip heights, what we need to do is actually move those grips into the right height. So let's grab some code from here, which is this one. Why am I doing this? Grips equals rs object grip locations. Curve new grips. I don't know why I'm storing that in a variable. That should be fine. So in grip heights. So what we're doing now is we've got a list of information, and we need a loop through that list of information to apply it to the list of grips that are on that curve. So the lists are identical in length and in structure. So there's nothing we have to do really to align them. The lists are just one to one. If you held them side by side, let me just draw that actually. So we have okay, so this is our list 1 or list 0 as and then we have another list over here, list 2. So computers always count from 0. So this is list 1, this is list 2. Each data point on there in that list is ordered in the same way as this list, and that's important because obviously this data needs to align with that data, so that it needs to be completely the same list, right? It can't be going like this or whatever. And this structure of data is sort of really important when you're, I mean, if you've ever used Grasshopper, you kind of get used to this idea of structuring the data in the same way so that you can actually align things back together. But I won't get too much into that because it's fairly boring. So What are we doing? rs.copy objects. Yep. So we're copying the curve because I don't want to delete or modify the original one. We're getting the height. So new group start a pen. Okay. So there's something I have to do before. Or this. I basically have to construct a new grip location, which is fundamentally just a new point. And you can see I'm doing that in here, so let's just copy that code as well. We also need to create an empty list as we did in the other logic stream. So for I and control points, why are we modifying that twice? Okay, so we're only interested in the Z value. Huh. Okay. So I wrote this code a little while ago before I knew about how to get index in for loops, but we'll just keep to the way I've done it here. This is a bit funky. I'm sorry if you're watching this and you're like, oh my god. But hey, this is can't always be perfect. No, we want to put that beforehand. So what's happening here is basically we're starting a variable and saying the starting variable is 0, and then as we loop through, the grep index, the variable gets and we can actually just change that to plus equals 1. We add 1 to this variable each loop, and that way we can go through each index and add the appropriate height. There's a better way to do that, but this is the way I've coded it. So we're just going to go with that. So what this is doing is going heights depend. Yep. Okay, so what this is doing is it's constructing a point. So from the original points here that it's grabbed, it's saying the point is the same as the X, same as the Y, there's no change. But for the Z direction, we're adding height. And it's looping through that and adding those points. So new grips.append equals new point, grip index plus equals 1. So that should loop through fine. And then we go for I and grip heights. We go curve enable. Okay. Let's run this. I don't think it's going to work, but we'll see. Enter 10. Ooh. 10 what did I enter? Oh. That's 0.10 meters. So maybe I do need height. I do need scaling. Do I? I mean, it's definitely done something. It's also added about 1 million different curves. So that is also an issue. So obviously I'm creating a new curve each loop I'm doing. Oh, why did I put that in a for loop? Wait, where? Okay, that should take care of that. So let's run that again. 10. Okay, now we've only got one curve being created, which is good. But it is being created not at 10 meters, but at 0.10 meters, which is not ideal. So why is that happening? Does it have to do with this? So what's coming out of non-param? So let's print non-param. By the way, this is in Rhino uses IronPython 2 point something. So this is saying I can't do this, but in this old version of Python, you don't need brackets around print. So what's coming out? So I think, okay, so so I need to times these by, I need to times the norm param by 100, right? To make them an actual percentage. So that's, I think that's what's happening there. So we'll go, we will wrap this and go times 100. We'll move into 10. Yep, that's certainly a lot bigger. Yep, that's 10 meters. Done. So you can now grade by height in a secret menu. Only people that have watched this entire stream will know. So basically, the what's happening now is after you've clicked your thing, your curve, an enter grade ratio number will come up. But if you hit enter and you've not entered anything to here, it'll fall back to enter height. So if you enter like 3 meters, because we're working in meters, it'll grade it to 3 meters. You can see here, which is great. So that one guy on the internet I don't know will be happy now, which is great. I don't think I'll ever use that, but yeah, that's fine. So let's, I mean, that's what all this is about. It's about, you know, open source software, kind of trying to push the needle a little bit in the architecture industry. It's all very, the architecture industry is all very closed. All the studios sort of have their own little internal team of nerds, and they don't share, which makes it really hard for like smaller studios to actually compete. So that's the reason kind of why I'm spending so much time developing all this code and putting stuff out there, is because, you know, no one else is. And our industry is really, really kind of archaic. Like the software we have is not great compared to other industries who are a lot better at sharing information and kind of working together. The architecture industry, not so great. So I'm just trying to do my little part even if it's a tiny part. Yeah. So I'm sort of flagging because of, as I said, I've got COVID. But I think that's probably a really good place to wrap up. So you've kind of seen what goes on trying to develop these things and realizing got so much time. But that's what makes it fun, you go through, you read the code, you forget what the code does, you try and remember what the code does, and you rebuild it and you make it better, and yeah, it's good fun. So I'm going to try and do this once a week at least, maybe a little bit more if I kind of in the mood. Probably not this week because I imagine the COVID's going to get worse before it gets better. Yeah. This was fun. And thanks for thanks. Yeah. I mean, like, I don't know how many people are going to be interested in this, especially in architecture and stuff. Designers, I've talked to a lot of designers and they get a very glazed look on their eyes when you start talking about code. But I think sort of the more you kind of show how powerful being able to code is, and how much you can make a difference with code, especially open source stuff. I'm a big proponent of it, just like sharing how to do things. Like the good thing about open source is that you can look at people's code and be like, oh, so that's how they did that. So hopefully someone looks at it, but if they don't, it doesn't matter. Yeah, thanks for the feedback. That's really cool. Yeah, I think that's about it. Every Sunday, hopefully. And I'm going to put these on YouTube as well. So that's going to be really good. Yeah, so I'll see you next week. Thanks for joining. See you guys.